Okay, this is our third and hopefully final video on radicals, and here we're talking about cubed roots, fourth roots, fifth roots. You'll see some of those here. The first one I asked you was a cubed root of 125, and on the side of the page I've listed my cube values, 1, 8, 27, 64, 125. 125 is on that list, so I'm looking for what I can take 3 times to get 125, so of course that answer there would be 5. Basically, anything we've done with a square root today, we could do with a cubed root and a fourth root, and a fifth root as well. Let's skip 81 and come back. The next one you see is a fraction. You can take the radical of the pieces. So the cubed root of 125 would be 5, and the cubed root of 27 would be 3. So this answer would just be 5 over 3. Let's stick with the cubed roots for a minute. What you'll notice about the cubed root here for 40 is that 40 is not a perfect cube. So you have to break it down into something that is and use the product rule. You know that 8 goes into 40, so we could break this down into the cubed root of 8 times 5, because 8 times 5 is 40. The cubed root of 8 is 2, and it would come out, so you would have 2 on the cubed root of 5. And so that's how they would work, same rules as before. Going back to 81, I didn't list out your fourth powers, but you can start with 2 and work your way up. 2 to the fourth power is 2 times 2 times 2 times 2, which would be 16. That doesn't work. 3 to the fourth power is 3 times 3 times 3 times 3. So that would be 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81. So that's it. 3 to the fourth is 81, so going backwards, the fourth root of 81 would be 3. Now, moving on, we can talk about negatives, and that's very tricky. But it says if n, that's your index, if the index is even, you cannot simplify the radical of a negative number and get a real answer. But if that index is odd, you can simplify it. And the reason is, if you take an odd number of negatives, you will get an odd answer. I'm sorry, I should have said negative answer. You'll get a negative answer. So if you said 3 negatives, that makes a negative. 5 negatives makes a negative. 111 negatives make a negative. So an odd number of negatives make a negative answer. But an even number of negatives gives you a positive answer. Because remember, you'd take them in pairs. Even means they go in pairs. So 2 negatives always make a positive. So 4 negatives would make a positive, and 6 negatives would make a positive, and so forth. So when we get ready to do these, we have to look at whether the index, that's this number here, is that index odd or even. Since this one is odd, that means I can take 3 negatives and get a negative result. My answer would be negative. 3 3's make 27, so the answer would be negative 3. Negative 3 times negative 3 times negative 3 would give me a negative 27. In the second one, there's not an index there. That means it's understood to be 2, which is even. You cannot take 2 real numbers and get a negative 25, so this answer here would be not real. In the last one, you have a 12 here. That's even. You can't take 12 values, real number values, and get a negative result. So this answer would also be not real. Okay, the next thing we have is our fraction exponent. And these are really easy. You will see them on your quiz and on your final. But a fraction exponent means radical. A fraction exponent means radical. So when I see this little fraction exponent here, that means change it to a radical, and this number right here is my index. Okay, and that should be easy for us to do. The square root of 16 is 4. Okay, looking at the next one, that's a 3. The cubed root of 27 is 3. Now you'll notice that both of these had 1 in the numerator. What happens if we have something other than 1? Well, you see a rule at the top. That rule doesn't help you all that much. So let's just try it by working it. 16 to the 3 halves. Well, 3 halves is a fraction exponent. That means turn it into a radical. So I'd start with this 2. So step 1 would be this step, turn it into a radical. You'll say, what about the 3? That's the second step. So the square root of 16 is 4. Okay, and that takes care of this 2 right here. Okay, so then you'll say, what happens to the 3? Well, that just becomes its own exponent. So 4 to the 3rd. Now don't multiply it and say it's 12. 4 to the 3rd is 4 times 4 times 4, which would be 64. And that's how it works. Looking at the next one, we would start with 5, the 5th root of 32. Okay, so what can I take 5 times to get 32? That answer would be 2. 2 to the 5th is 32. Here's my top number, 2 to the 3rd. 2 to the 3rd is 2 times 2 times 2. It is not 6. 2 times 2 times 2 would be 4 times 2, which is 8. And that's what we would get with that one. Now, in this part, we talked about fractional exponents, and we see their relationship to radicals. But then we have to use our exponent rules and simplify expressions with them. So in the top one, we're just simplifying these expressions. The first thing I would do is say 2 times 7 is 14. Okay, so get the easy part out of the way first. And then you have to use your exponent rules. And the rule here says when you multiply with like bases, you add the exponents. Okay? Now bear with me, it's not writing well. So if I add these exponents, I'm going to have 1/2 plus 2/5. Okay, 1/2 plus 2/5. Okay. So in order for me to add those, I need a common denominator. So I'm going to say that is 1/2 plus 2/5. I'm going to turn them both into tens. If I multiply by 5 on the bottom, I have to multiply by 5 on the top. If I multiply by 2 on the bottom, I have to multiply by 2 on the top. So I'm going to get 5/10 plus 4/10 gives me 9/10. Now 9/10 is not my answer. So this is going to give me 14x and 9/10 is my exponent. And that's how that piece would look. Now if you look back at the notes, it wrote over my signs a little, so I'm going to try to fix that. There we go, maybe that's a little bit better. Okay, looking at the second one, that's your dividing properties for exponents. So remember, if you divide with like terms, you subtract the exponents. Now, but before we can get there, it's just basically 20 divided by 5. Well, I know that 20 divided by 5 would give me a 4 in the top. So 20 divided by 5 would give me 4. That's how we start. Now your exponents here are 4 over 1. I'll go ahead and turn it into a fraction. And 3 over 2. We need to get a common denominator, so we can pick 2. This one's already 2. So we'll turn the top one into 2. So we're going to get 4x to the 8 over 2 over x to the 3 over 2. So you get a 4 in the top. 8 halves minus 3 halves would give us 5 halves. You can put it over 1 if you want to, or you can just say it's 4x to the 5 halves. Okay, our last concept, you can use the power rule. For those of you interested, the power rule works, or you can just remember to change it to a radical, and I prefer change to a radical. So this would be the square root of 64, x11, y18. Now, what do we do with the 2, that index? Well, the first thing, the easiest part, is to say the square root of 64 is 8, the whole number 8. Okay, so that's how we would deal with that part. But you'll say, well, what do you do to the exponents? And the rule is you divide them. So you're going to say 11 divided by 2 and 18 divided by 2. The 18's easy, the 11's not. So I'm going to come to the side. Actually, what you see there is x, talking about the x, to the 11 over 2. Because remember, the index is on the bottom. So the way that I do that, you can do it in your head, or you can divide it out using long division. 2 goes into 11 5 times, and that would give me 10, with 1 left over. You'll say, now why do you want to do that? Well, if you look at my long division, it tells you where the x's go. If it's a number on top, that means those are the x's that come outside. So for this x, we would have x to the 5 outside. See this remainder? That's how many x's remain, since it's a remainder, inside. So that means you're going to have 1 x left over underneath the radical. So 2 goes into 11 5 times with 1 left over. It goes 5 times, so that means 5 x's come out and 1 x goes inside. You'll say, well, what about the 18? Well, what I know about y to the 18 over 2? 18 over 2 gives me a whole number. That gives me 9. So that means I would have 9 y's outside with no y's left inside. And that's how that one would look. So moving to the last one, we're going to turn this into a radical, and I'm going to say it's the cubed root of 8, x14, y22. Okay, first of all, the cubed root of 8 is 2, whole number 2. So we would start with a 2 there. Okay, and then we have to get to the 14. Well, that would be x to the 14 over 3. Well, dividing that out, 3 goes into 14 4 times, which would give me 12, and 2 left over. So that means I'm going to have 4 x's outside and 2 x's left underneath. Now remember, it's a cubed root, so remember your index. So then you get to the 22. This would be y to the 22 over 3. Well, 3 goes into 22 7 times with 1 left over. So you would have 7 y's outside and 1 y left inside. And that's how it would look.